Hi everyone, I was recently messing about with gravity simulations and ended up making a little solar system which you could fly about and explore. It's hard to get terribly excited about exploring a bunch of coloured spheres though, so today I'm embarking on a journey to generate some simple procedural moons and planets. I need a sphere to begin with, so this bit of code is one way of calculating the points, and it allows me to control the number of vertical and horizontal segments, which means I can control how detailed the planet will be. Unfortunately, a lot of that detail is clumped around the poles, so this probably isn't the right sphere for me. But plenty of fish in the sea. For example, if you've seen this video of mine on boids, you may recall me getting wildly sidetracked by something called the Fibonacci sphere. This is a really cool method which allows us to choose exactly how many points we want, and they're really evenly spread out as well. I had no idea though how to turn these points into triangles to create a mesh, because they aren't calculated in a neat winding order like the previous method. But I found this interesting post which explains that you can project the points onto an infinite plane, triangulate those, and then wrap it back up into a sphere. I thought that was really clever, but I wouldn't mind something a little more straightforward, so I'm going to keep exploring my options. 6 planes can be arranged to form a cube, and if we then force the points to all be the same distance from the center, we get the humble cube sphere. What's cool about this technique is that each face can be divided into smaller subfaces, which means you can render nearby regions of a planet in high detail, but save rendering time on more distant areas. There's a lot of work I still need to do on this though, fixing the gaps and lighting issues that occur at the seams, which seems like quite a headache, so since my goal for now is just simple miniature planets, I'm going to have a look at another celebrity sphere, the icosphere. To create this one, I learnt that you start with 3 rectangles with side lengths in the golden ratio. If you then join the points at the corners to form 20 triangles, you have an icosahedron, which is apparently ancient Greek for 20 seat, in case you were wondering. In any case, each triangle can then be divided into 4 sub-triangles, and those new points projected onto the sphere. We can repeat that as many times as we want to increase the resolution. The only trouble is the number of vertices grows really rapidly with each division, so you don't have such fine control. At this point, I came across an article about different types of spheres, and in the comments was Ben Golas, describing a different approach where you simply add however many points you want along the edges of each triangle, and connect them up like so. I spent a while figuring out all the index math for this on paper, which worked out great for me as you can see. But I swapped some numbers around and eventually ended up with something where I have decent control over the number of points and a pretty good distribution as well. Here's my code for this, which is probably many times longer and more convoluted than it needs to be, so nothing unusual there. What I'd like to create first from this sphere is a little moon with a surface covered in craters, and to do that I'll need to calculate a height for each vertex. I have quite a lot of vertices, so I'm going to do this in a compute shader so that I can process loads of them in parallel on the GPU. Compute shaders can be unbelievably fast, but they also have this distressing habit of finding new and creative ways of crashing my computer, so it's a bit of a love-hate relationship. Anyway, I'll get the current vertex position and then write a value to my height buffer based on that. So as a little test run for example, I'll try 1 plus the sign of the position on the y-axis multiplied by some test value. This will then be used elsewhere in the code to actually modify the height of that vertex. So I'll open up my shape settings here, and if I increase that test value, we can see the sphere wobbling along with the sine wave. So with my basic setup working, I've begun looking at some craters. I basically just need to create a little bowl-shaped cavity with a raised rim around it, and also a lot of craters seem to have flat floors formed from shattered and melted rock. Larger craters also undergo some fascinating transformations. For example, gravity causes the walls to slump down into step-like formations, and somehow the ground is also pushed up to form these giant central peaks, or in some cases, rings of peaks. I then fell down a bit of a rabbit hole reading about the man who spent 27 years mining for the wealth of iron meteorite he figured had caused this crater, only to then learn it had been vaporized in the impact. More distressingly, I came across the so-called Mimas moon in orbit around Saturn. Wake up, sheeple, that's no moon. I should probably get back to work. So I need to try come up with some equations to describe the basic shapes of a crater. For the cavity, for example, I can just use a simple parabola like this. To form the rim, I experimented with a bunch of things, but what I ended up with was another little parabola mirrored around the x-axis, which can be shifted horizontally with the rim width parameter, and contracted or expanded using the rim steepness parameter. Then for the floor of the crater, I'll just have a straight line which I can shift up and down. Now to combine these three equations together, I'll make a crater shape function, and this will first take the minimum value between the cavity and the rim, resulting in this, and then take the maximum value between that and the floor, which gives us the overall shape. The lack of transition between the functions makes the shape really harsh and unnatural though, so several episodes ago, back when I was experimenting with ray marching, I learnt about the smooth min function for blending shapes together. This function just takes whichever is smallest between a and b, but with some smoothing applied, controlled by the parameter k. To make this return the max instead of the min, you can just make k negative, by the way. So if I use that for my craters and increase the smoothing parameter, you can see it looks a lot more natural. I now just need to translate that to my moon height compute shader, and behind the scenes I'm also now feeding it a buffer containing a random position and radius for each crater, plus all the various settings it needs. Then, going into the scene, I'll increase the maximum radius, and we can see a single crater appear. Let me add in a bunch more of these, and to try get them looking a bit more crater-like, I'll mess about with the rim width and steepness parameters, and then also the smoothing amount to make the shapes a little less harsh. That's looking okay, so I'll add in a bunch more of them. It looks terrible now, but I think what would help is if smaller craters were a lot more common than larger ones. So I'm generating a random number between 0 and 1 to determine the size of each crater, and if we pass that value into this function that I'm graphing here, we'll just get out the exact same thing we put in, because y is equal to x at every point. So that's pointless. But here's the code for this function, and as you can see, it's controlled by a parameter called bias. The bias is currently 0, but as I increase it towards 1, you can see how the curve changes. So now, most values we input to the function will just get a small output, and only a few will result in a relatively large output. Back to the moon. I can now use this little slider to change the distribution of the crater sizes, and make small craters more common than larger ones. The last parameter to play around with is the floor height, and currently this affects all of the craters, but I'm going to make a little change to have the floor height determined per crater, just to add some variation. Alright, that was very long-winded, but we now have some fairly cute little craters. The moon is exceedingly smooth at the moment though, so I want to add some little bumps and ridges using noise. The noise function I'm using just takes in a point in space and gives back a value between -1 and 1, which changes smoothly as you move the point around. The code for that noise function, which is not something I wrote myself, looks like this. Very confusing. Anyway, we can make multiple layers of increasing detail by spacing the sample points further and further apart each time. If we combine all these layers into one, well, it's a bit of a mess, but if we make it so that each layer contributes less and less to the overall result, we get some nice structured and detailed noise out of it. The code for that looks like this. We can do some fun things with it. For example, we're sampling the noise function at a point in space, so what if we offset that point using more noise? Well, as it turns out, this warps the noise in pretty cool ways. If you add a bit of color and animate some values, you can get some pretty stunning results. Modifying it another way by taking 1 minus the absolute value of the noise results in a more ridge-like appearance, useful for, well, ridges and mountains. I had some fun playing around with different colors and just watching the noise scroll by. Just for fun, let's try use this to create something similar to Hyperion, one of Saturn's less threatening, lumpy, spongy-looking moons. So I have some different noise settings over here, like the ridge noise I was just talking about. This has a bunch of parameters I can play with, like the scale and the power. Looks great. We can also subtract the ridges instead of adding them, which I think looks kind of interesting. Anyway, to get a kind of lumpy shape like Hyperion, I'll add some simple noise and scale the frequency way down. I can then offset the sample position until I get a shape that I like. I'll then also add some higher frequency noise for a bit of detail. Hyperion had a lot of holes punched in it, so I'll put the number of craters way up to something like 3000, and it's quite amazing that my terrible crater code, which loops over every single crater on every single vertex, is actually still running reasonably quickly. Anyway, here's my little rock. If I want to add more detail without increasing the number of vertices, I'll need to use textures. So typically, someone creates a 3D model and then painstakingly adds seams to indicate how it can be unwrapped into 2 dimensions. A talented artist then draws details on top of that, and we get our beautiful result. To bypass the annoying unwrapping step, I'm going to try use a technique called Triplanar Mapping, and the idea is to just use the position of the model's vertices to read from the texture. Of course, the position is in 3 dimensions and the texture in 2, so over here I've just picked the x and y axes of the position to sample from the texture. This gives great results when we're looking into the xy plane, but from other directions it's somewhat less convincing. So the idea continues, we sample the texture 2 more times using the zy and xz axes. Now we just need to blend between these 3 different textures to favour whichever one aligns best with the surface, which we can do based on the surface normal. We can also raise the normal to some power to affect the sharpness of the blending, and multiply the position by some factor to control the scale of the texture. If we look at the sphere now, you can see it's blending between the projections, but the result is kind of muddy, and that's what the sharpness parameter was for. I can fiddle with that and get it looking how I want. Also, if I change the scale parameter, surprise surprise, it scales the texture. I'll grab one of those textures from my warp noise experiments to use instead. This needs some lighting, so I'll quickly go back into the shader and calculate the dot product of the surface normal and the direction towards the light source, and then multiply the output color by that. This looks a bit bland though, so I'd like to spice things up with a normal map. I did some research on how to get that to work with triplanar mapping, and once again Ben was there to guide the way with this very detailed article on the subject. So here's the triplanar code now modified to work with normal maps. In my fragment shader, I can then get the normal from the normal map and use that to calculate the lighting. I found these 2 handsome maps online, so let's try them out. Immediately the surface looks a lot more interesting and detailed than it really is. Here's what the other map looks like. So I'll switch over to my actual moon surface and raise the strength of the normal mapping. Here I'm actually using both normal maps and blending between them based on some noise to try break up the repetition a bit. What I'd like to do next is add some color variation, so I've generated some noise which is stored in the mesh UVs, and using that I can split the moon into 2 color regions. I also have some settings for warping that noise because I like warping everything now. One little detail I wanted to add is these cool looking rays of ejected material you can see around relatively young craters, before exposure to space darkens them and they fade into the background. To do this, I randomly pick a couple of craters to have this feature, and I then did some slightly suspicious maths to calculate UV coordinates around them, like so, and it can then sample from a texture to draw the rays. This doesn't look great to be honest, and it only works for a small number of craters, but it's better than nothing for now, I think. There's clearly still a lot of room for improvement of the moons, but I'd like to move on for now and begin creating some little planets. So I'll write a little shader that just uses the fractal noise from earlier to create some landmass shapes. I'll smooth out the lower values to create an ocean bed, and then I'll multiply all heights below 0 by an ocean depth parameter. I'll then also add in some ridge noise for mountains, and finally add those noises together and write it to the height buffer. So here's the noise in action. I'll deepen the oceans and flatten the floor a little, and then I'll go into the ridge noise settings and push up some mountains. The only trouble is the mountains have kind of taken over, and I'd like to retain some flat areas. So I'll add another layer of noise to act as a mask, and I'll multiply the mountain noise by that mask. So now if I shift the mask around, I have some control over how abundant the mountains are. Here's what the mask actually looks like, by the way. Now, I'm not sure what the best way to handle the oceans is, because I want the player to be able to go underwater. What I'm going to try for now is doing it as a post-processing effect. So after everything else has been drawn, this shader will be run for every pixel on the screen, and in here we can access the camera's depth texture to figure out how far away everything is, otherwise the ocean would just be drawn on top of everything. I then collaborated with Stack Overflow to write this little ray sphere intersection function, which can tell me the distance to the surface of a sphere, and also the distance it travels through it to the other side. In my ocean shader, I'll then use that function to figure out how much water we're actually looking through for the current pixel. If it's more than nothing, I'll draw white, otherwise I'll just leave the original color. That gives me this. To add some color, I'll go back to the shader and use the depth of the water to blend between a shallow and deep color, and also blend in some of the original color in shallow regions to give a soft transition at the shore. So I can control the transparency with this parameter, and the blending of the shallow and deep colors with this one. I can also obviously change the colors. Now, I'd like to be able to see the sun in the water, so I looked up the equations for specular highlights and decided to go with the Gaussian model because apparently it's slightly better. Citation needed. The calculation is kind of expensive though, primarily because of this arc cosine function, which I hear is a big no-no in shaders, so I might replace this with a cheaper model later. I'll then also add some diffuse shading and apply this lighting to the ocean color. So I can now use the smoothness slider to control the size of the highlight, and behind the scenes I also added in some wave-like normal maps using that same triplanar technique from earlier, and that gives a kinda nice effect. It would of course be a lot nicer to have actual waves rising and falling, but I have no clue how to do that, especially using this technique on a sphere. Something to look into for sure. Now, with the way I've done this, it is possible to go underwater, but the effect is quite underwhelming at the moment. Still, I'm going to call it good enough for now, and move on to colouring the terrain. In one of my old tutorial series, I tackled this problem by assigning colours based on elevation, but this results in kind of silly looking bands of colour. I've learnt at least one new trick since then though, which is to consider the steepness of the terrain, calculated as the dot product between the surface normal and the up direction at that point. We can then make grass, for example, appear only where the steepness is below a certain threshold. I do still use the elevation to not allow grass to grow too high up, and also to add some slight colour variation. Something I've been struggling with a lot is the look of the mountains, because they look too smooth. I tried adding in a rocky normal map, but it looked a little bit horrendous. In an earlier iteration, I experimented with flat shading, and also adding a threshold so that only steep regions would be flat shaded, but I wasn't so happy with this either. Ideally, I'd like to use a technique I experimented with a while back where you simulate hundreds of thousands of droplets of water to try and mimic the effects of erosion. Just thinking about the changes I'd have to make for this to run on a spherical world seems like it'd become ridiculously slow though, so my latest attempt has been this kind of cartoony effect, with solid bands of colour to try emphasize the rockiness a bit. I'm not sure if that's the style I want to go for or not, but I've been experimenting a bit, adding for example this sort of speckled effect to the grass. Up close you can see the terrain looks a bit raggedy, so I do think it would help if I could increase the resolution some more. I have several levels of detail that I can switch between, but that's just for the entire planet, so I think I might need to break it up into chunks after all. Headaches await me, I guess. Anyway, we can of course randomize the planet shape, which just works by changing where in space the noise values are sampled from. And we can randomize the colors, although the combinations can sometimes be a bit of an eyesore. I've then also been having some fun generating other little planets and moons to fill up my test solar system. For example, here's one that I've nicknamed Cyclops because of its one giant crater. I quite enjoy just messing about with the settings and seeing what happens. As you can probably tell, there's a lot of warping going on in this one, so I'll play with that parameter a bit as well. Cyclops has a little moon, based on those Hyperion experiments from earlier. There are a bunch more, but I'm quickly going to hop over to Blender and try whip up a blocky little astronaut so we can go explore them properly. I'll get this imported into the game, make a build, and oh no, what have I done this time? Well, that was weird, but here we are by the home planet, and alongside it is its little moon. I'm going to see if I can zip over there quickly. Well, let's go see what's out there. Looks like a whole lot of nothing. I'll head back to the ship because there's not actually much to see here, but maybe several episodes down the line there'll be some little life forms to gawk at or something. For now though, I'll just hop over to the next door planet. Oof, good thing I haven't added a damage system yet with the way I pilot this thing. So obviously things are kinda wonky looking at the moment, but if I can work on the graphics a bit and add in some trees and bushes and maybe some little life forms as I mentioned earlier, I think it could potentially be a nice little place to wander about. For my last stop on today's journey, I'll fly over to the twin planets which orbit up close and personal with the Sun, and I'll go pay a little visit to the Fire Twin. That's going to be all from me for today. Obviously there's loads of things I could do to improve the look of the moons and planets, I just wish I knew what they were and how to do them. But that just means there's loads left to learn, so I'd better get to it. As always, I hope you've enjoyed watching, and until next time, cheers.